Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math B4, Variant 3, May-June 2022. Let's get started. Here is part of a bus timetable. Rashid catches the 9:20 bus at Abbots. Find the time the bus arrives at Southmore. If Rashid catches the 9:20 bus at Abbots, then the bus arrives at Southmore at 10:07. Anissa leaves home at 8:27 a.m. and takes 25 minutes to walk to the bus stop at Scarlett. She catches the next bus to Center Point. Find the total time in minutes for her journey from leaving home to arriving at Center Point. 8:27 a.m. is 8:27 on the 24-hour clock. If Anissa leaves home at 8:27 and takes 25 minutes to get to the bus stop at Scarlett, then she arrives at 8:52. This means she is able to catch the 9:42 bus and arrives at Center Point at 10:30. So now to get the total time for her journey, we subtract 8:27 from 10:30. Under the minute column, 30 minus 27 is 3, and under the hour column, 10 minus 8 is 2. So we have 2 hours, 3 minutes. To convert 2 hours to minutes, we multiply 2 by 60. This gives us 123 minutes. The distance from Abbots to Center Point is 29.4 kilometers. Each bus takes the same time for the journey. Calculate the average speed of a bus for this journey. Give your answer in kilometers per hour. We can use this formula to get the average speed. We've been given the distance between the two towns to be 29.4 kilometers. We are told each of the buses takes the same time for the journey, so we can use the times of any of the bus to get the time duration. Let's pick the first bus. So to get the time duration of the first bus from Abbots to Center Point, we subtract 6:50 from 8 o'clock. Under the minutes column, we can't subtract 50 from 0, so we get 1 hour from the hour column, which becomes 60 minutes under the minutes column. So 60 minus 50 is 10. Under the hour column, 7 minus 6 is 1, so we know the time duration is 1 hour 10 minutes. To convert 10 minutes to hours, we divide 10 by 60. When we type this into the calculator, we get 25.2 kilometers per hour. On one journey, all 56 seats on the bus are filled. The ratio of adults to children on this journey is adults is to children equals 5:3. The cost of an adult ticket is $2.8. The cost for a child ticket is 3/4 of the adult cost. Work out the total cost of the tickets for this journey. First, let's find the number of adults and children. To get the number of adults, we divide the ratio share of the adults, which is 5, by the total ratio of 5 plus 3, which is 8, times 56. This gives us 35. For the number of children, we have 3/8 times 56, which is equal to 21. We've been given the cost of an adult ticket to be $2.8. To get the cost of a child ticket, we take 3/4 of $2.8, which is equal to $2.1. So the total cost of the tickets is equal to the total cost for the adults, which is 35 times $2.8, plus the total cost for the children, which is 21 times $2.1. This gives us $142.1. Draw the image of triangle T after a reflection in the line y equals x. First, we need to draw the line of reflection, which is y equals x. Then we reflect each vertex on triangle T in the line y equals x. This means if we pick point C on triangle T, since we move 3 units to the right to touch the line of reflection, then we need to move 3 units downwards from the line of reflection to pin the new position of point C. After repeating the same process for all the vertices on triangle T, we are now able to map out the reflected image of triangle T. Draw the image of triangle T after a translation by the vector -1, 3. For this translation, the translation vector dictates that we move each of the vertices of triangle T 1 unit to the left and 3 units upwards. On the diagram, the movement for point B has been shown. After repeating the same process for points A and C as well, we are able to map out the translated image of triangle T. Describe fully the single transformation that maps triangle T onto triangle A. When we look at triangles T and A, we can tell straight away that this is an enlargement by a scale factor of 1.5 because each of the sides of triangle A is 1.5 times its corresponding side on triangle T. This is a negative scale factor because the two triangles do not have the same orientation. Triangle A is flipped, so now we need to find the center of enlargement. To get this, we connect at least 2 corresponding points on both triangles. The intersection point of the lines is the center of enlargement, which in this case is 0, 3. And so the full description for this transformation will be enlargement by a scale factor of -1.5 about the center 0, 3. A quadrilateral P is enlarged by a scale factor of 1.2 to give quadrilateral Q. The area of quadrilateral P is 20 centimeters squared. Calculate the area of quadrilateral Q. Quadrilateral P is enlarged by a constant scale factor to get quadrilateral Q. This means the two shapes are similar. For similar shapes, the ratio of their areas is equal to the square of the ratio of their corresponding sides, which is 1.2. When we make the area of quadrilateral Q the subject, this is what we have, which is equal to 28.8 centimeters squared. The table shows the number of tigers reported to be living in the wild in the year 2014 in some countries. Using the table, find the number of tigers in Nepal as a percentage of the number of tigers in Bangladesh. To set up the percentage, the number after the of, which in this case is the number of tigers in Bangladesh, would be the denominator. So we have the number of tigers in Nepal, which is 198 divided by 106 times 100%. This gives us 187% rounded to 3 significant figures. Using the table, find the ratio. Tigers in Bangladesh is to tigers in Indonesia is to tigers in India, given your answer in its simplest form. For the ratio, we have Bangladesh is to Indonesia is to India equals 106 is to 371 is to 2226. The highest common factor of the numbers is 53. When we divide through the ratio by 53, we get 2 is to 7 is to 42. 5 years later, the number of tigers reported in India was 2,967. Find the percentage increase in the population of tigers in India. The percentage increase is equal to the increase in tigers, which is 2,967 minus 2,226, divided by the initial number of tigers, which was 2,226 times 100%. This gives us 33.3% rounded to 3 significant figures. The number of tigers in India in the year 2014 is approximately 30.48% greater than in the year 2010. Find the number of tigers in India in the year 2010. Give your answer correct to the nearest integer. The number of tigers in 2014, which was 2,226, is equal to 100 plus 30.48%, which is 130.48% of the number of tigers in 2010. When we make the number of tigers in 2010 the subject, this is what we have. When we type this into the calculator, we get 1,706 rounded to the nearest integer. At the start of June, a hive has a population of 2,000 bees. 3 months after the start of June, the hive has a population of 2,662 bees. The population of this hive can be calculated using the formula P equals A times B raised to the power X, where P is the population of the hive X months after the start of June. By finding the value of A and the value of B, calculate the population of the hive 7 months after the start of June. Give your answer correct to the nearest integer. In the given formula, A represents the initial number of bees, which has already been given as 2,000. So now let's find the value of B. We are told 3 months after the start of June, the hive has a population of 2,662 bees. So we have 2,662 equals 2,000 b cubed. When we divide both sides by 2,000, we have b cubed equals 1.331. When we take cube root of both sides, this is what we have. Cube root of 1.331 is 1.1. Now that we have the values of A and B, the population of the hive 7 months after June is 2,000 times 1.1 raised to the power 7. When we type this into the calculator, this is what we have, which is approximately 3,897 rounded to the nearest integer. A regular 12-sided polygon has side length 6 cm. Show that one interior angle of the polygon is 150 degrees. The formula for the size of an interior angle of a regular polygon is 180 degrees times n minus 2 divided by n, where n in this case is 12. This gives us 150 degrees. The polygon is enclosed by a circle center O, so that each vertex touches the circumference of the circle. Show that the radius AO of the circle is 11.6 centimeters, correct to 1 decimal place. First, we need to find angle OAB, which is half of the interior angle of the polygon, which we found to be 150 degrees, giving us 75 degrees. So now to get AO, we apply SOHCAHTOA. This gives us cos 75 equals 3 centimeters divided by AO. When we make AO the subject, this is what we get. When we type this into the calculator, this is what we have, which is approximately 11.6 centimeters rounded to 1 decimal place. Calculate the circumference of the circle. Here is the formula for the circumference of a circle. The radius r of the circle, which is OA, is 11.6 centimeters. When we type this into the calculator, we get 72.9 centimeters rounded to 3 significant figures. Calculate the perimeter of the shaded minor segments formed by the chord AB. The perimeter of the minor segments is equal to AB plus the minor arc AB. AB is 6 centimeters. Before getting the length of the minor arc AB, we need to get angle AOB. OA and OB are equal, so triangle OAB is isosceles. Base angles in an isosceles triangle are equal. So to get angle AOB, we subtract 2 times 75 degrees from 180 degrees, which gives us 30 degrees. To get the length of the minor arc AB, we have 30 degrees over 360 degrees times 2 pi r, where the radius r is 11.6 centimeters. When we type this into the calculator, we get 12.1 centimeters, rounded to 3 significant figures. The regular 12-sided polygon is the cross-section of a prism of length 2 centimeters. Calculate the volume of the prism. Here is the formula for the volume of a prism. In this case, the length of the prism is 2 centimeters, and the cross-section of the prism is in the shape of a 12-sided polygon, whose area is 12 times the area of triangle AOB. The area of triangle AOB is half base times height, where the base is 6 centimeters. To get the height, we apply SOHCAHTOA. This gives us tan 75 equals h over 3 centimeters. When we make h the subject, we get h equals 3 tan 75 centimeters. When we type this into the calculator, we get 806 centimeters cubed, rounded to 3 significant figures. The time T minutes taken by each of 80 people to travel to work is recorded. The table shows information about these times. Write down the class interval containing the median time. To get the position of the median, we use the formula half n plus 1, where n is 80. This gives us 40.5. To get the interval in this position, we start adding the frequencies from the smallest time interval. So 3 plus 7 is 10. 10 is less than 40.5, so we add 18 to 10, which gives us 28. 28 is less than 40.5, so we add 28 to 28, which gives us 56. 56 is greater than 40.5. This means the time interval t is greater than 20 and less than and equal to 35 contains the median time. Calculate an estimate of the mean time. Before we get the estimate of the mean time, we need to find the midpoint of the given time intervals. So for the first interval, the midpoint is 0 plus 5 divided by 2, which is 2.5. Then we have 5 plus 10 divided by 2, which is 7.5. 10 plus 20 divided by 2, which is 15. 20 plus 35 divided by 2, which is 27.5. 35 plus 60 divided by 2, which is 47.5. So the mean is equal to the total amount of time taken by the 80 people, which is 2.5 times 3 plus 7.5 times 7 plus 15 times 18 plus 27.5 times 28 plus 47.5 times 24 minutes divided by 80. When we type this into the calculator, we get 28 minutes. One of these 80 people is chosen at random. Find the probability that this person took longer than 10 minutes to travel to work. Give your answer as a fraction in its simplest form. This probability is equal to the number of people who took longer than 10 minutes, which is 18 plus 28 plus 24, divided by the total number of people, which is 80. When we type this into the calculator, we get 7 over 8. 2 people are chosen at random from those taking 20 minutes or less to travel to work. Calculate the probability that one of these people took 5 minutes or less and the other took more than 5 minutes. The probability that the first person chosen from the group of people who took 20 minutes or less took 5 minutes or less is equal to the number of people who took 5 minutes or less, which is 3, divided by the number of people who took 20 minutes or less, which is 28. After the first person is chosen, the pool reduces by 1. So the probability that the second person chosen from the 20 minutes or less group takes greater than 5 minutes is 25 over 27. The order in which these two people are picked may be reversed, making the number of possible orders in which they are chosen to be 2. So we multiply this by 2. When we type this into the calculator, we get 25 over 126. Use the frequency table on page 8 to complete the cumulative frequency table. For t is less than and equal to 20, the cumulative frequency is 3 plus 7 plus 18, which is equal to 28. For t is less than and equal to 35, the cumulative frequency is 28 plus 28, which is equal to 56. On the grid, draw a cumulative frequency diagram to show this information. On the grid, we plot the points in the cumulative frequency table and connect the points with a smooth line, starting from the origin. Find an estimate for the 80th percentile. To get this, we first find 80% of 80, which is 64. When we map 64 from the vertical axis onto the graph, we get the 80th percentile to be 40 minutes. Find an estimate for the percentage of people who took longer than 45 minutes to travel to work. Show all your working. First, let's find the number of people who took longer than 45 minutes. So we map 45 minutes from the horizontal axis onto the graph, which gives us 70. This represents the number of people who took 45 minutes or less. So to get the number of people who took longer than 45 minutes, we subtract 70 from 80. So the percentage is 80 minus 70 divided by the total number of people, which is 80, times 100%. This gives us 12.5%. Simplify a minus 2b minus 3a plus 7b. When we group like terms, minus 2b plus 7b is 5b. A minus 3a is minus 2a. Expand and simplify. 4 times x minus 5 minus 3 minus 2x. When we expand the brackets, 4 times x is 4x. 4 times negative 5 is negative 20. Negative 1 times 3 is negative 3. Negative 1 times negative 2x is 2x. When we group like terms, 4x plus 2x is 6x. Minus 20 minus 3 is minus 23. So we have 6x minus 23. Write as a single fraction in its simplest form. To write this as a single fraction, we cross multiply, giving us 3 times 2x minus 7 times x minus 5. Then we divide by the LCM, which we get by multiplying the denominators of the two fractions. When we expand the brackets, 3 times 2x is 6x, minus 7 times x is minus 7x, minus 7 times minus 5 is 35. When we group like terms, 6x minus 7x is minus x. So we have 35 minus x over 2x times x minus 5. Solve 13 minus 4x over 3 equals 6 minus x. When we multiply both sides of the equation by 3, this is what we have. When we expand the brackets, 3 times 6 is 18. 3 times minus x is minus 3x. When we group like terms, this is what we have. 4x minus 3x is x. 13 minus 18 is negative 5. Make x the subject of the formula y equals 5 times p minus 2x over x. When we expand the brackets, 5 times p is 5p. 5 times negative 2x is negative 10x. When we multiply both sides by x, we have yx equals 5p minus 10x. When we move all the x terms to one side of the equation, this is what we have. When we factor out x, we are left with y plus 10. And when we divide both sides by y plus 10, we have x equals 5p over y plus 10. The diagram shows a field ABC. Calculate BC. To get BC, we apply the cosine rule to triangle ABC. This gives us BC squared equals AB squared plus AC squared minus 2 times AB times AC cos angle BAC. AB is 82 meters, AC is 55 meters, and angle BAC is 76 degrees. When we plug in these values into the equation and make BC the subject, this is what we get. When we type this into the calculator, we get 87.0 meters, rounded to 3 significant figures. Calculate angle ACB. To get angle ACB, we apply the sine rule to the triangle. This gives us sine of angle ACB divided by 82 meters equals sine 76 divided by 87.0 meters. When we make angle ACB the subject, this is what we get. When we type this into the calculator, we get 66.1 degrees, rounded to 1 decimal place. A gate G lies on AB at the shortest distance from C. Calculate AG. The shortest distance from C to AB is the perpendicular line from C to AB. So point G is the point where this perpendicular line meets AB. To get AG, we apply SOHCAHTOA to triangle ACG. This gives us cos 76 equals AG over 55 meters. When we make AG the subject, this is what we get. When we type this into the calculator, we get 13.3 meters, rounded to 3 significant figures. A different triangular field, PQR, has the same area as ABC. PQ is 90 meters and QR is 60 meters. Work out the two possible values of angle PQR. We've been told the area of triangles ABC and PQR are equal. To get the area of the two triangles, we apply the formula half AB sine theta. So for triangle ABC, we have half of 82 times 55 times sine 76. And for triangle PQR, we have half of 90 times 6 times sine of angle PQR. Half of 82 times 55 times sine 76 gives us 2,255 sine 76. Half of 90 times 6 gives us 2,700. When we make angle PQR the subject, this is what we get. When we type this into the calculator, we get 54.1 degrees, rounded to 1 decimal place. To get the second possible value of angle PQR, we use the quadrant and we measure 54.1 degrees from the horizontal axis in the quadrant where sine is positive. From this, we see that the second possible value of angle PQR is 180 degrees minus 54.1 degrees, which is equal to 125.9 degrees. A has coordinates -2, 7, B has coordinates 1, -5, and C has coordinates 5, 4. Find the coordinates of the midpoint of the line AB. To get the midpoint of AB, we apply the midpoint formula. So for the x-coordinate of the midpoint, we have -2 plus 1 divided by 2, which is equal to -0.5. And for the y-coordinate of the midpoint, we have 7 plus -5 divided by 2, which is equal to 1. Find vector AC. AC is equal to OC minus OA. OC is 5, 4 and OA is negative 2, 7. To get the resultant vector, we subtract corresponding elements in the two vectors. So 5 minus negative 2 is 7 and 4 minus 7 is negative 3. So we have 7, negative 3. Find the magnitude of vector AC. To get the magnitude of vector AC, we need to apply the magnitude of a vector formula. This gives us square root of 7 squared plus negative 3 squared. When we type this into the calculator, we get 7.62 rounded to 3 significant figures. Find the equation of the line AB. Give your answer in the form y equals mx plus c. All we need to do is to find the values of m and c and plug in these values into y equals mx plus c. To get the gradient m of AB, we apply the gradient formula. This gives us 7 minus negative 5 divided by negative 2 minus 1, which is equal to negative 4. To get c, we plug in the value of m and one set of coordinates. In this case, we are using the coordinates of A into y equals mx plus c. This gives us 7 equals negative 4 times negative 2 plus c. Negative 4 times negative 2 is 8. When we subtract 8 from both sides, we get c equals negative 1. So we have y equals negative 4x minus 1. Find the equation of the line perpendicular to AB that passes through C. Give your answer in the form y equals mx plus c. In this case as well, we need to find the values of m and c and plug in these values into y equals mx plus c. If this line is perpendicular to AB, then it means the product of the gradient of this line and the gradient of line AB, which is negative 4, must be equal to negative 1. When we divide both sides by negative 4, we get the gradient of the line to be 1 over 4. We know the line passes through point C. So to get the value of C for the line, we plug in the value of M and the coordinates of point C into y equals mx plus c. This gives us 4 equals 1 over 4 times 5 plus c. 1 over 4 times 5 is 5 over 4. When we subtract 5 over 4 from both sides, we get c equals 11 over 4. So we have y equals 1 over 4x plus 11 over 4. The graphs of y plus 5x equals 8 and y equals 2x squared plus 6x minus 13 intersect at the points P and Q. Find the coordinates of P and the coordinates of Q. Show all your working. To get the coordinates of P and Q, we need to solve the equations of the two graphs simultaneously. First, let's label the equations of the graphs. We will be using the substitution method. So if we put equation 1 into equation 2, this is what we have. When we move all the terms to one side of the equation and group like terms, this is what we have. We can solve this quadratic equation using the factorization method. We can rewrite 11x as 14x minus 3x. For the first two terms, when we factor out 2x, we are left with x plus 7. And for the final two terms, when we factor out negative 3, we are left with x plus 7. This can be rewritten as 2x minus 3 times x plus 7 equals 0. When we equate 2x minus 3 to 0, we get x equals 1.5. And when we equate x plus 7 to 0, we get x equals negative 7. So now we can plug in the x values into any of the equations to get their corresponding y values. Let's pick equation 2. When x is 1.5, y plus 5 times 1.5 equals 8. When we make y the subject, we get y equals 0.5. When x is negative 7, y plus 5 times negative 7 equals 8. When we make y the subject, we get y equals 43. Sketch the graph of y equals x plus 1 times 3 minus x times 3 plus x, indicating the coordinates of the points where the graph crosses the x-axis and the y-axis. At the point where the graph crosses the y-axis, the x value is 0. So when we plug in x equals 0 into the equation of the graph, we have y equals 0 plus 1 times 3 minus 0 times 3 plus 0, which is equal to 9. At the point where the graph crosses the x-axis, the y value is 0. So when we plug in y equals 0 into the equation of the graph, we have x plus 1 times 3 minus x times 3 plus x equals 0. When we equate x plus 1 to 0, we get x equals negative 1. When we equate 3 minus x to 0, we get x equals 3. And when we equate 3 plus x to 0, we get x equals negative 3. After plotting these points, we need to pick some random x values and plug in these values into the equation of the graph to get their corresponding y values. Then we plot these points as well to help us sketch the shape of the graph. Show that y equals x plus 1 times 3 minus x times 3 plus x can be written as y equals 9 plus 9x minus x squared minus x cubed. First, let's expand the first two brackets. So x times 3 is 3x. X times negative x is negative x squared. 1 times 3 is 3. 1 times negative x is negative x. When we group like terms, 3x minus x is 2x. When we expand these two brackets, we have negative x squared times 3 is negative 3x squared. Negative x squared times x is negative x cubed. 2x times 3 is 6x. 2x times x is 2x squared. 3 times 3 is 9. 3 times x is 3x. When we group like terms, minus 3x squared plus 2x squared is minus x squared. 6x plus 3x is 9x. Calculate the x values of the turning points of y equals 9 plus 9x minus x squared minus x cubed. Show all your working and give your answers correct to 2 decimal places. At any turning point, dy dx equals 0. When we differentiate the equation of the given curve, we get dy dx equals 9 minus 2x minus 3x squared, which we equate to 0. To solve for x, we apply the quadratic formula and this is what we get. The numbers under the square root, negative 2 squared minus 4 times negative 3 times 9 gives us 112. And for the denominator, 2 times negative 3 is negative 6. For the first value of x, we get negative 2.10 rounded to 2 decimal places. And for the second value of x, we get 1.43 rounded to 2 decimal places. The equation 9 plus 9x minus x squared minus x cubed equals k has one solution only when k is less than a and when k is greater than b, where a and b are integers. Find the maximum value of a and the minimum value of b. In other words, we are to find the line y equals k that cuts the graph of y equals 9 plus 9x minus x squared minus x cubed at one point. So first, we need to find the corresponding y values for the x values of the turning points of the curve. When we plug in x equals negative 2.10 into the equation of the curve, we have y equals negative 5.049. And when we plug in x equals 1.43 into the equation of the curve, we get y equals 16.90. In the illustration, we see that the lines y equals k, where k is less than -5, cuts the graph at only 1 point. So the maximum value of k in this range is -6. We also see that the line y equals k, where k is greater than 16, cuts the graph at only 1 point. So the minimum value of k in this range is 17. The diagram shows a cuboid ABCDEFGH. CG is 6 centimeters, AG is 24 centimeters, and AB equals 2BC. Calculate AB. If we represent the length of BC with x, then it means the length of AB is 2x. Before we get x, we need to find AC. To get AC, we apply the Pythagoras theorem to triangle ACG. This gives us 24 squared equals AC squared plus 6 squared. When we make AC the subject, this is what we get, which is equal to 6 root 15. Now that we have AC, we can get x by applying the Pythagoras theorem to triangle ABC. This gives us 6 root 15 squared equals 2x squared plus x squared. 6 root 15 squared is 540. 2x squared is 4x squared. When we group like terms, this is what we get. And when we divide both sides by 5, we have x squared equals 108. When we take square root of both sides, we get x equals square root of 108. Now that we have the value of x, AB equals 2 times square root of 108 centimeters. When we type this into the calculator, we get 20.8 centimeters, rounded to 3 significant figures. Calculate the angle between AG and the base ABCD. On the diagram, we've labeled the angle between AG and the base as theta. To get theta, we apply SOHCAHTOA. This gives us sin theta equals 6 centimeters divided by 24 centimeters. When we make theta the subject, this is what we get. When we type this into the calculator, we get 14.5 degrees, rounded to 1 decimal place. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.